So children, we will start from where we stopped, exactly where we stopped in the last class. This is Rijuan PSK, online classes, tele classes, physics classes, low motion classes. Okay. Now I asked you what will happen in the last situation. Hope you have studied all these details in back at home, and now you know that this component of force is pulling the velocity backward, so the speed will decrease, speed decreases. And what about direction? Direction changes. And the direction changes. Now I tell you this first condition, the first condition is observed in motion in a straight line when the body is speeding up. For example, you drop something, that speed will increase because of this relation, because velocity is downward, force is also downward, there is no change in direction. This happens when you throw a body upward. As long as it's going upward, speed will decrease, direction will not change. This is what happens when you brake your car in the road. The friction from the ground will oppose you and that will decrease your speed, but the direction is still forward. This one happens in uniform circular motion. Take a stone, tie it in a string, whirl it like this. Every time you are pulling it to the center, perpendicular. Velocity tangential, force perpendicular, centripetal force. Uniform circular motion. This is one of the reasons why the speed of earth does not change in spite sun is attracting us. Sun attracts, but the direction is perpendicular to velocity, so speed will remain same every time. This happens in projectile motion. When you throw a body, projectile motion, these two cases will happen. There is speed increasing, there is speed decreasing. When it goes from the ground to the highest point, this is the case. Speed decreases, direction changes. From highest point to downward, this is the case. Direction changes, speed increases. So this is what you have in all motion that you have to study. Everything. The DNA of all motion in our syllabus. Not rotational motion, all other motion. Here it is. Fine. So I think you should make a big photograph of this one and keep this framed in your visiting room, in your drawing room, because this will help you learn many things in detail. Okay. Let us go to next question. A body of mass 5 kg is acted upon by two perpendicular forces 8 Newton and 6 Newton give the magnitude and direction of the acceleration of the body. Okay. This is the application of force in the component form. You remember force in the component form. You remember that one. I told you Fx will give you m into Ax, Fy will give you m into Ay, and Fz will give you m into Az. Okay. Now assume that there is a body, maybe in space, not in contact with anything, there is a body, and there are two perpendicular forces acting. Let us say this is 8 Newton and there is a force here which is 6 Newton, perpendicular. You want magnitude and direction of the acceleration of the body. There are two ways of doing this. You can find out acceleration along the x direction and acceleration along the y direction, then you can find out. Okay, let us go for that method first. Fx equal to m into Ax. So what is acceleration in the x direction? That is force in the x direction by mass. What is force in the x direction here? Let us say this is x direction, this is y direction. Force in the x direction is 6 divided by mass is 5, this much meter per second square. What is the other component? Fy is nothing but m into Ay. So acceleration in the y direction is nothing but force in the y direction by mass, and force in the y direction is 8 divided by 5 meter per second square. Okay. What is the total acceleration? The total acceleration is nothing but square root of acceleration in the x square plus acceleration in the y square component form, which is equal to root of 6 by 5 square plus 8 by 5 square. And you can see that 5 square is common for both of them, that you can take outside. So this will give you 1 by 5 into root of 6 square plus 8 square. 6 square plus 8 square is how much? That is 36 plus 84, 100. Root of 100 is, this is root of 100. So that gives you 10 by 5, answer is 2 meter per second square. And what is the direction of this acceleration? You should have studied this idea, tan theta with x-axis. Tan theta with x-axis is always y component by x component. So we can say tan theta is equal to ay, y component is 8 by 5, x component is 6 by 5. So that gives you 4 by 3. So we can say tan theta is 4 by 3, or theta is equal to tan inverse 4 by 3 with the x-axis. That's the point. With the x-axis. So this is x-axis. From that one, tan inverse 4 by 3. What is tan inverse 4 by 3? Think about the triangle. Tan inverse 4 by 3. This is 4, this is 3, this is 5. This angle is theta. That is 53 degrees. So this is 53 degree from x-axis, or 53 degree from 6 Newton. That's the best way of expressing it. From 6 Newton at 53 degree. That means it's closer to 8 Newton. This is using the component form. The other method is finding the resultant in the beginning. Okay, I think this part is okay. Let me erase this. The next method is find a resultant force. Resultant force is given by F in the x direction square plus F in the y direction square, and that is like a 6 square plus 8 squared under the root will give you 10 Newton. Now acceleration is nothing but the magnitude of the force divided by mass, which is the resultant force divided by mass will give you 2 meter per second square. I use parallelogram law. And from parallelogram law, I can see that this is my parallelogram, this is how the force acts, this is how the acceleration will work, and I can find this angle. Let me call this angle as theta. And you can say that tan theta is equal to, this side is 8, this side is 6, that is like 8 by 6. So theta is equal to tan inverse 4 by 3, and that will give you 53 degree from 6 Newton. Resultant force, I calculated the resultant force. So this is a component. So you can see that this 6 Newton will produce acceleration in this direction, that 8 Newton will produce acceleration in this direction. When they act together, the body will have a resultant acceleration along this direction. That is it. And you can also see that the resultant acceleration is making a 53 degree from 6 Newton, that means 37 degree from 8 Newton. It's closer to 8 Newton because 8 Newton is the strongest force. Also think that if these two forces were equal, the resultant and the acceleration would have been at 45 degree. Okay. Right. Next one. This is going to be complex. Many times students tell me that they don't follow this. They did not follow this. Watch carefully. A body of mass 0.4 kilogram moving initially with a constant speed of 10 meter per second to the north is subjected to a constant force of 8 Newton directed towards the south. The body was going towards the north direction and the force is acting in the south direction. So the two are opposite, so that is a retarding force. For 30 seconds, the force acted only for 30 seconds. After that, before 30 there was no force, after 30 also there is no force. Take the instant the force is applied to be t equal to 0. So when did the force started acting? At t equal to 0, and that means from 0 to 30 seconds there was a force. And that position should be taken as x equal to 0. Predict its position at t equal to minus 5 seconds. Can time be negative? Minus 5 seconds, 25 seconds, 100 seconds. What is the meaning of this minus 5 seconds? 5 seconds before 0. So the force acted at a particular instant, right? Before that, 5 seconds before, force was not there. Okay, I think this will be easy if you draw a diagram. If you draw a diagram, this will become easy. I need a straight line here. I don't know how far I will be able to draw the straight line. So this is a straight line. Okay, it starts from somewhere, so it can be extended. It starts from somewhere. And on this straight line, there is a point called x equal to 0. This point is called x equal to 0. This is positive side of x and this is negative side of x. And the body was coming, okay, let me say north and south, because the body one is north and south. Let me say this is the north side and this is the south side. North side and south side. Now, what was the body doing? The body was coming with a constant speed of 10 meter per second to the north. It was coming from south to north like this. Where is t equal to 0? T equal to 0 is the point here. So, here you have t equal to 0. At t equal to 0, force acted. And what is the direction of that force acting? The force acted on the, see, the body was coming from this one. I can say the body was coming in this direction. And what was the speed of the body? It was coming with a speed of 10 meter per second. And the body reached this point, a force started acting in this direction. How much force started acting in that direction? There was a force of 8 Newton. Now what will happen? The body was coming in this direction. What will happen if there is a force? There will be a retardation. The retardation will act for some time. And see, this is like throwing a body upward. You throw a body upward, velocity in this direction, velocity is in this direction, but acceleration is in the opposite direction, force is in the opposite direction. What will happen if you throw anything upward? Will it go forever upward? It will not. It will go for some time, then it will stop for a moment, then it will return. It will return in the direction of the force. That's the point in this question. This particle will go in this direction, then somewhere here its velocity will become 0. After that, this will start moving like this. It will go. Is that clear? It will go that direction, stop there, then return. Now this is t equal to 0. So where is t equal to minus 5? T equal to minus 5 must be somewhere here before reaching x equal to 0. So you can say at t equal to minus 5 it was here. So from minus 5 to 0 time, minus 5 to time 0, it was going with a constant velocity. But at t equal to 0, force started acting, and the force started acting for 30 seconds. I don't know where the particle is at 30 seconds. Probably the particle stopped here and started moving in this direction. So somewhere here, maybe this is the 30-second time. There is one more time given, 25 seconds. So given 25 seconds, it could be here, and at 100 seconds, it can be somewhere there. And when you discuss minus 5 seconds, you should know that between minus 5 and 0, there was no force. But from 0 to 25, there is a force. When you talk about 100 seconds, you should know that from 0 to 30, there was a force, but beyond 30 to 100, there is no force. If there is no force, it's uniform motion. If there is a force, that is accelerated motion. If the force is constant, so that is uniformly accelerated. So this is the whole picture. Okay. Once more. Now this time, a smaller diagram will be enough. This is a straight line. Take this point as t equal to 0. So I need to be talking about t equal to minus 5, that is past. Then somewhere here t should be equal to 25 seconds. Somewhere here t should be equal to 30 seconds. And somewhere here t should be equal to 100 seconds. And there is some time where the particle will stop. Now let me draw the path. The path of the particle. The path of the particle, let me say, we need to start talking about minus 5 seconds, okay, minus 5 seconds to 0 second, 0 second to somewhere it stops. From there this will go, and there is a point 25 seconds, there is a point 30 seconds, and there is a point 100 seconds. So these are the different instances in which I have interest in. Let me calculate acceleration of the particle. Acceleration is nothing but force divided by mass. And what is the force given? That is given as 8 Newton, and the mass is 0.4. And this will give you 20 meter per second square. See, the force is acting towards the south. So this acceleration is also towards the south, opposite to the initial velocity. One more point, at t equal to 0 to t equal to 30, there was the force and acceleration, and that acceleration was towards the south. But see that from t equal to 0 till it stops, force and velocities are opposite. But from there onwards, force and velocities are in the same direction. So the particle will experience a retardation from 0 to this point, where it stops momentarily. Read it as momentarily stop. Till it stops, force and velocities are opposite, but after that, the force and velocities are in the same direction. It is exactly like, see, you stand on a tower, you stand on a tall building and throw a body upward. What will happen? That will go up, then fall downward. Same motion. It goes, then falls. So I got acceleration. Now let me calculate position. Okay. At minus 5 seconds, at t equal to minus 5 seconds. We can see that from minus 5 to 0, this is x equal to 0. From minus 5 to 0, it was in uniform motion. So we can say displacement is equal to velocity into time. Displacement is nothing but final position minus initial position. This is nothing but velocity into t initial minus, or rather maybe you are familiar with this equation, x2 minus x1 equal to v into t2 minus t1. Okay. Now the body was moving at t equal to 0. This is the first position, this is the final position. Initial and final position. So x2 is 0 minus x1 equal to v is given as 10, velocity is 10, into t2. T2 is minus 5. T2 is 0, T1 is minus 5. So we'll get this as x1 is equal to, x1 equal to minus 50. x1, or rather maybe I will simplify this, calculation. I can directly use s is equal to v into t. Why to go to complexity? This is 10 and what is time? Minus 5. This will give you minus 50 meter. So we can say at t equal to 0 it is at 0, but at t is equal to minus 5, this is at minus 50. That means to the negative side. That is the position at t equal to minus 5 seconds. I just took a t equal to minus 5 and calculated it. Okay. Now that is okay. So that part is okay. Now at 25 seconds, you know it is under force. There is force acting. So that is accelerated motion. So that is written as ut plus half a t square. And what is u? U equal to 10 positive. Time is 25 plus half into acceleration is opposite to the velocity. So I should take it as minus 20. Be careful. Why minus? Because that is opposite to the initial velocity is plus, that is to the north direction. This acceleration is to the south. That's why it's minus into 25 square. This gives you 250 minus 20 by 2 is 10 into 25 square is 625. That gives you 620, 6250 minus 250 will give you 6000 minus. Minus, that means from the origin x equal to 0, it has gone 6 kilometer in this direction. That is the position at x equal to 25 seconds. Okay, that part is over. Now you want position at 100 seconds. Position at 100 seconds, be careful, position at 100 seconds, see this. See this, from t equal to 0 to t equal to 30, it was accelerated. So we use that as s equal to ut, 10 into 30, just the previous one, plus half into minus 20 into 30 square. This gives you 300 minus 10 into 900. Yeah, 30 square, sorry. 30 square is 900. This gives you 9000 minus 300 minus 8700 meter. So from 0 to 30 second, it had a displacement of minus 8700. That means from origin it has gone to that side, but it went up to minus 8700. From there, what will happen? That is 30 second. At that point, the force will stop, because force acts only for 30 seconds. Force will stop. What will happen? When the force stops, what is the velocity? That's what I want to tell you. Velocity when force stops. V is the equation. V equal to u plus at. V is equal to 10 plus a equal to minus 20 into t is equal to 30. This is minus 600 plus 10. This gives you 590 minus meter per second. Minus means now that is moving towards the south. Minus 590. Now with this speed, it will travel further. So up to 30 seconds, it travel minus 8700. Displacement is minus 8700. But after that, that is going with the constant velocity. So we can say from 30 to 100. From 30 second to 100 second. Okay, that is uniform motion. So displacement is equal to V into T. V is equal to minus 590 into 70. Minus 590 into 70. How did I get 70? Because from 30 to 100, that is only 70 second available time. 70 into how much is this? This is 4200. How did you calculate this? Please calculate this. So if you calculate, you will get minus 41,300. That means, see, from 0 to 30 second, it was at minus 8,700. But from there, again, it has got another displacement, minus 41,300. Okay. So I will show you here. That means, this was x equal to 0. From x equal to 0, see here, up to this point, this one. This was 8,700. This was 8,700. From there again, I calculated to 100. So this is a second region, this region. From 30 to this one. And how did I get how much did I get? I'll get this as 41,300, and both are in the negative direction, that's why minus signs. Now what is the total of these two? At 100 second, it is a sum of these two. So position at 100 second. So position at 100 second is the sum of these two, minus 41,300 plus minus 8,700. And how much is that one? This gives 1000, this will give you minus 50,000. That's it. This is the position after 100 second. This will take some time to digest, practice it. Because without yourself working, you can't study this. Okay. Fine. Now from conceptual physics, a little bit mathematical physics. Okay. The velocity of a body of mass 2 kg as a function of t is given by 2ti plus t square j meter per second. Find the momentum and force acting on it at time equal to 2 seconds. There is no k here, that's a mistake, I will rewrite it. Okay. If there is a unit change, the value will have different units. Okay. So the velocity is given as, it's a function of time. What is the meaning of v of t? V of t means the velocity keeps changing with time. How does it change with time? 2t in the I direction, that means in x direction. 2t in the I direction, 2t in the I direction plus t square in the j direction, that much meter per second. Is it one dimensional or two dimensional? This is two dimensional. It moves along the x axis and it also moves along the y axis. I tell you, along the x axis it's a uniform motion. No, along the x axis it is uniformly accelerated motion, velocity is proportional to t, and along y axis it is non-uniformly accelerated motion. Find the momentum and force acting on it at time t equal to 2 seconds. Okay, let us calculate the momentum. How do we calculate the momentum? Momentum, actually, see, this is a velocity vector. So the momentum vector at a time t is nothing but mass into velocity vector at that time. So that gives you m into velocity. What is mass? That is 2 into 2ti plus t square j. Okay, so this gives you 2 into 2 4ti plus 2t square j kilogram meter per second. So this is the momentum of the particle which is varying with time. You want momentum at t equal to 2 seconds. What to do? At t equal to 2 seconds, substitute. What do you get? You will get a 4 into 2i plus 2 into 2 square j kilogram meter per second. This gives you 8i plus 2 into 2 square is again 8j kilogram meter per second. This is the momentum at that time. If you want to take the magnitude, you can go for the magnitude, that will be giving you 8 root 2 kilogram meter per second. 8 kilogram, 8 square plus 8 square under the root. Now you want force acting. How do we calculate force from the momentum? See this, force is nothing but derivative of momentum, dp by dt. So we have to differentiate this equation of momentum. Okay, so what will you get? You will get f varies with the time t as derivative of 4ti plus 2t square j. What is derivative of 4t? See, you separately differentiate this, 4ti differentiated, that give you 4i, it should be 4i plus this you can differentiate 2 into 2 4tj, 4tj, that much of Newton. This is the equation for the force acting on it. And at the given time at t equal to 2 seconds, this force will have a value, this force will have a value F is equal to 4 is constant, not affected by time, plus 4 into 2, 8j Newton. Okay. So that is the force acting. If you want magnitude, you can just take the modulus thing. Okay, if you want force magnitude, then take 4 square plus 8 square. That's it. So what did we do? We have the velocity equation. From the velocity equation, we calculated the momentum equation. For the momentum equation, we applied the time. We got the value. For force, what we did is that we differentiated it. We differentiated the x component and y component separately. X component differentiated, you got 4. Y component differentiated, you get 2 into 2, 4t. Then you put t equal to 2 seconds, you get the answer. Okay. This is about 2 billiard balls colliding. Okay. What is the question? Read that. 2 billiard balls, each of mass 0.05 kilogram, moving in opposite directions with the speed of 6 meter per second, collide and rebound with the same speed. What is the impulse imparted to each ball by the other? We want to calculate impulse. So we know the idea that impulse equal to change in momentum. Impulse equal to change in momentum. Let us assume that the balls are A and B. They were coming in the opposite direction. So this had a speed of 6, this also had a speed of 6. Now after collision they collided here, okay, they collided, then they started moving. A and B again started moving, B started moving in this direction with 6 speed, this is started moving in this direction with the speed c. This A and B. Okay. Now, who changed momentum of A? That is the impulse imparted by ball B. What is the impulse imparted to each ball by the other? Okay, so we will say impulse. This is the idea. Impulse imparted on A. Impulse imparted to each ball by the other. Impulse imparted on A by B equal to change in momentum of A. That's the idea. Okay, maybe I'll make it a little more simpler to see. Okay, I'll write like this one. You want impulse imparted on A, and who is imparting it? That's of course B. By B is equal to, what is it? Change in momentum. You remember the definition, the force, the impulse of the force is equal to change in momentum of the body where force is applied. Change in momentum of A, that's what you want. And change in momentum delta P of A is equal to P final of A minus P initial of A. P final of A minus P initial of A. And what is P final? Let us assume directions here. Okay, let us say rightward is positive, leftward is negative. So this is positive 6, this is minus 6. After collision, this is minus 6, this is positive 6. For A, final is minus 6, initial is plus 6. And what is the mass of each body? 0.05. So we'll see this thing is nothing but final. This is final. 0.05 into minus 6. I hope you understood minus 6, final velocity. Minus 0.05 into initial is 0.6. Okay. And this is actually, see, both are equal magnitude. This is minus 0.05 into 6 into 2. Minus of minus. Okay. Minus 2 MB. You studied that, minus 2 MB. You could have directly used that equation, 2 MB. Fine. How much is this thing? This is like this is 0.1, this is 0 minus 0.6 Newton second. 2 into 0.05 is 0.1, 0.1 into 6 is 0.6 Newton second. This is on A. Work out the same way with B, and the answer will be different only by its sign, because for B, final is positive, initial is negative. You can see for B, final is positive, initial is negative. Naturally for B, the delta P of B will give you plus 0.6 Newton second. And that is the impulse imparted by the other. And you can see that minus sign is leftward. B will apply impulse leftward, A will apply impulse rightward. So your answer is correct, both logically and mathematically. Okay. Next one, it's about a machine gun. A machine gun fires a bullet of mass m with the speed v. The person holding the gun can exert a maximum force F on it. What is the number of bullets that can be fired from the gun per second? If you have seen Hollywood movies and all, there are movies where they show firing from heavy guns. There was one movie, I think it's called Rambo. Sylvester Stallone, he was holding a huge gun and firing. And during that firing, you can see that his entire body shakes. It's not a simple plastic toy to fire with a gun. You need tremendous amount of force and energy to hold a large gun and fire. Reason, when the gun bullet goes out of the bullet goes out of the gun, then there is a backward force acting. We will discuss it later. That's why we need a force to create that one. How are we going to solve this thing? Listen carefully. Listen carefully that each bullet was initially at rest inside the gun. When you fired it, it came out with a velocity v. That is, the initial velocity was 0, final velocity is v. Okay, I may write here initial velocity u equal to 0. Final velocity equal to v. Fine. Now time is given here. They are giving you time. What is the time given? Time is given 1 second. See, per second. Time is given as 1 second. Okay. Now, how many number of bullets are there? Let's say number of bullets is n. You are firing n bullets. Okay, leave it. No need to take this as, let us take as a t. So, you are firing n number of bullets in a time t. One bullet will have a change in momentum. So, n bullet will also have change in momentum. Okay. So, write like this one. Change in momentum of one bullet, that is delta p equal to p final minus p initial, which is equal to final momentum is mv, initial momentum is m into 0, because initial velocity is 0. That is for one bullet. So, this gives you mv. Now, I will write the same thing, change in momentum for n bullets. For one bullet mv, for n bullet the change in momentum will be equal to n into m into v. Okay. So, that is calculated. Now, what do you want? You want the force to be acting, force. Okay. So, how do we calculate force? Force is equal to delta p by delta t, and that is nothing but n into m into v divided by the time taken is t. And what is n by t? Here this can be written as n into m into v, and this n is the number of bullets fired per second. So, we have an equation for force and number of bullets fired per second, F equal to n into mv. What is given? F is given, m is given. How many numbers can be fired in a second? So, that is easy. Number of bullets fired in a second is nothing but force divided by mv. Force is given to you, v is given to you, mass is given to you. From that one you can find out the number of bullets fired. Okay. So, dear children, in the NCERT textbook laws of motion, you will see these exercises, exercise number 1, exercise number 2 and so on. Okay. This is it. So, I will say this one, not this one, from here onwards, this exercise in NCERT, then this exercise in NCERT based theoretically, no numerical things in that one, and this exercise in NCERT. Please work out all these questions so that we can discuss this and find answers in the next class. Thank you for your time. Bye.